Hi everyone, the question is the number of ordered pairs a comma b of integers, that means a and b are supposed to be integers, such that a minus b is the root of this quadratic x square plus ax plus b equal to 0 is. So we'll just satisfy a minus b being a root of this equation, we'll satisfy this equation by a minus b, and this essentially becomes what? A minus b whole square plus a times a minus b plus b equal to 0. So what I have is b square minus 2ab plus a square minus ab plus b equal to 0. So let me see this as a quadratic in b square, and you have plus b 1 minus 2a, rather 1 minus 3a 3a plus 2a square equal to 0. So it is like a quadratic in b, and I can write b in terms of a using the formula for root of a quadratic. So you have minus times coefficient of b, 3a minus 1 plus minus under root 3a minus 1 whole square. Here let me write 3a minus 1 whole square minus 4 times 1 times 4 times 1 times 2a square, so 8a square. So what you have is you have 9a square minus 8 square. So essentially it will be a square minus 6a plus 1, divided by 2. So here b is an integer, that means b is rational also. So that means a square minus 6a plus 1 should be a perfect square. So you may say what? A square minus 6a plus 1 is equal to, let's say, k square. Now without loss of generality, let me consider this k to be non-negative. So let me say it as non-negative integer. Because if a is integer, a square minus 6a plus 1 is also an integer, and for b to be an integer, hence rational, a square minus 6a plus 1 should be a perfect square. So you may see this as a minus 3 whole square. A minus 3 whole square, you have done plus 8, so you will do plus 8 on other side also, but this k square you can take on left side and you put it like this. So what you have is you have a minus 3 plus k times a minus 3 minus k is equal to 8. Now here a, 3, k all are integers. In fact k we have considered to be non-negative integer. Nonetheless, both these factors would be integers, and their product being 8, you can see these two factors as factors or divisors of 8 positive or negative. So here one possibility is you may consider it to be 8 1, or you may consider it to be minus 1 minus 8. The reason I am taking 8 1 and not 1 8 is that k we have taken k to be non-negative integer. So no matter what, a minus 3 plus k would be greater than or equal to a minus 3 minus k. So and we have not lost generality in any way. So 8 1 minus 1 minus 8. Another possibility is 4 2 2 4 we would not take, minus 2 minus 4. So here if you see carefully, if a minus 3 plus k is 8 and a minus 3 minus k is 1, as you add you get a minus 3 to be 9 by 2, which is not possible. A is supposed to be an integer, so a minus 3 would also be an integer. Similarly here you get a minus 3 to be minus 9 by 2, again rejected. Here you get a minus 3 as 3, that means a is 6, and here you get a minus 3 as minus 3, that means a is 0. Now you may say, okay sir, then k should also be an integer. It is automatically taken care of as such. If a is an integer, and given that a minus 3 plus k is 4, which is an integer, k will turn out to be an integer. Here a itself was not turning out to be integer, then whether k turns out to be integer or not doesn't matter. In fact, it will not be an integer as such. Nonetheless, A is 6 or A is 0. Now if you put A to be 0, you can put it here, you get B to be 0 or minus 1. So B can either be 0 or minus 1, yeah, belongs to. And when you put A to be 6, B can be, if you see carefully, 17. 17 plus 1 by 2, 17 minus 1 by 2, 8 or 9. So it can be 8 or 9. So that means these ordered pairs A comma B can be either 0 comma 0, 0 comma minus 1, 6 comma 8, 6 comma 9. So there seems to be 4 such ordered pairs. So answer should be B. Thanks for listening.